All right. Hey guys, so I'm going to choose my challenge level here. The game that we're going to play, or the puzzle, is a Ken, one of my favorites, a Ken. And I'm going to choose one with a little bit bigger sized grid. So we practiced a 3 by 3. I'm going to bump it up to a 5 by 5. I'm going to choose to have all of the operations. I think it's more fun that way. I'm going to keep it on the easiest for now, but in the future, you can ramp it up in the challenge level with difficulty. So we're going to play. And then we're going to see, let's get rid of all this. We're going to see here that we have a 5 by 5 grid. So that implies that our digits we can use are 1, 2, 3, 4, and 5. Every row has to have a 1, 2, 3, 4, and 5. Same with every column. It not only has to only have one, but it can only have one of each digit. So I'm going to go in and look for the have tos. What I notice first is there's these single boxes. Those are awesome because it tells you exactly just what has to go in there. We have 2 of those that I observe. So then what I might do next is I'm going to look for numbers where it might seem like there are fewer options. So I'm going to look for some multiplication. I find that with addition, there tends to be more options. So I like to save those once I have a few more clues. So I'm going to go up here to this 10. So using these digits down here, I know that 4 is not a multiple of 10. I know that 3 isn't either. So the only way we can make this is with a 5 and a 2. So I'm just going to write a 5 and a 2. Now, again, we don't know which order those are going to go in, so I'm writing them smaller here. But somewhere in there, those have to be a 5 or a 2. Same here. Let's see, 5 with multiplication. Well, the only way to make that is 5 times 1. So I'm going to write it kind of small, 5 and a 1. So that means down here, these digits have to be either a 2, a 3, or a 4. And I haven't even looked at the math yet, but I just know based on the column, if up top you are using a 5 and a 1, these have to be a 2, a 3, or a 4. Okay, so then we can look and say, math-wise, can that work out? Well, 2 times what would get me 12? 6. We can't use a 6, so this can't be a 2. Okay, so then 3 times 4 is 12. So this has to either be a 3 or 4 as well. Okay, so then I'm just going to keep going this way and see what happens. So then we'll say, okay, well, if I need to end at 4 using subtraction, I know I have to start obviously bigger than 4. So I need to use a 6, can't use a 6, 5. So I need to start with a 5 and subtract 1. So this has to be either a 5 or a 1. So far in this row, we've used a 1, not a 2, a 3, 4, and 5. So this has to be a 2. Using addition, we need to get to 7, so this is going to become a 5. And then in this column here, we see that the digits we still need to use are a 1, a 3, and a 4. Well, I know I can rule out 4 here because using multiplication, 4 obviously is not going to work to land on a 3. So this is a 1, 2, 3. This has to then become a 4 and a 5. We have all the digits used in this column in some way. We don't know yet which one will go here and there, but we know it has to be. So here, looking here, we know using subtraction, we want to end at 1. So I could start at 5 and take 4 away to get to 1, or I could start at 4 and take 3 away to get to 1. Right here, 3 using addition. Oh, well, the only digits we can do are 1 and 2. So if this has to be a 1 or a 2, then in here we know this cannot be a 2. We already have a 4 in this row, so this right here has to be a 3. Okay, so then if that's a 3, this can't be a 3. This can't be a 3, so this right here has to be a 4. This is what I like to call the snowball. It all starts to fall into place. So this has to be a 2. Wow, that's a 2. And we know that these 3 boxes this time, because they're all connected with the thicker black lines, have to multiply together to get 6. 3 times 2 times 1 gets us that. So the last digits we have in this row are a 3 and a 4. We already have a 3 here, so this has to be a 4. This has to be a 3. And you can kind of see that it's going to keep going and keep snowballing. You're looking for the have to moments where a number has to go. If it could go there, you write it in smaller writing. If it has to go there, you write it in bigger writing.